Alright, so the other day, Wednesday, we were solving quadratic equations that look like that, and we were solving them using a technique called completing the square. Alright, so can anybody remind me how that worked? Alright, we add the 4 to the other side. That's a good start. Okay, added the 4 to the other side. You've got to do something before you can figure out the magic number. You've got to divide by the 3. You've got to have a 1 right here. So before you can figure out the magic number, you've got to divide by 3 right here. So divide by 3, and of course we do it everywhere. Unfortunately, that's going to give us a fraction over there on the right. We'll live with that, I guess. That's x squared minus 4x equals 4/3. All right, now you're right. Now we need to figure out the magic number and add that magic number to both sides. It's 4, and how did you get 4? You take this number in the middle, which is negative 4. You always divide it by 2, and then you always square it. That's negative 2 squared, which turns out to be 4. So we're going to add 4 to both sides of that equation. The reason we do that, the reason that's the magic number, the left-hand side now factors in a really, really nice way. How does x squared minus 4x plus 4 factor? It's x minus 2 and x minus 2 again, so we write it as x minus 2 squared. Over here on the right, I add, I think of 4 as being 12/3, so I get a common denominator. 4/3 plus 12/3 is 16/3. All right, now why did it help? What we've done at this point, when we get to here, this is called completing the square. We've written the left-hand side so that it's a perfect square. And why did that help us? Now we can square root both sides. And what do square roots and squares do to each other? They reduce each other out. So we end up with x minus 2 equals plus or minus the square root of 16/3. And then finally, how do we get the x all by itself? We add the 2. X equals 2 plus or minus the square root of 16/3. Alright, so that's what we did last time. Today what we're going to do is we're going to do pretty much exactly the same thing, except instead of some nice numbers, we're going to have a whole bunch of letters. And a cannot be the number 0. How come I say a cannot be the number 0? Because I'd have 0x squared, which means this wouldn't be quadratic anymore. If a is 0, this piece would go away, and I'd just have a linear equation. We know how to solve linear equations. All right, so we're going to do exactly the same process that we did a minute ago, except we're going to use letters instead of numbers. So, as you recall, the first thing we did is we took this number and we moved it to the other side. So we're going to take the number here is just the letter C, and move it to the other side. That would be ax squared plus bx equals negative c. And then we decided that this number in the front had to be the number 1. So we divided by 3 up here. Same deal here. This has to be the number 1, so we're going to divide by a. So we have x squared plus b over ax equals negative c over a. Lots of letters. All right, our next step was to find the magic number. What was our technique for finding the magic number? I take the middle number, which in this case is b over a. I divide it by 2, and then square it. All right, so I'm going to take b over a divide by 2, and then square it. All right, how do I take a little old fraction like b over a and divide it by a regular old number like 2? How do I take a fraction and divide it by a number? I think of 2 as being a fraction, think of it as being 2 over 1, and I flip and multiply. So this becomes b over a times a half, and then we have to square it. Well, I'm going to write that as b over 2a, and then square it. Multiply tops, multiply bottoms. That's b squared over 4a squared. All right, so there's my magic number, although it has lots of letters this time. There's my magic number that I add to both sides. Plus b squared over 4a squared. Plus b squared over 4a squared. I add that to both sides. Now, if I did everything right, if I did everything correctly, the left-hand side should factor in a very nice way. The left-hand side should factor as x plus something squared. The big question is, what's the something? B over, sounded good. B over 2a. Why is it B over 2a? Last class I said that the number that goes here is always the thing that you had right here right before you did the squaring. That's right, and notice it worked here. We had a negative 2 right before we did the squaring, so we ended up with x minus 2 in there. And that's always the case. It's always this thing right before you do the squaring. So that's b over 2a. On the right-hand side, I'm just going to do a little work here. First off, I'm going to switch the order. So I'm going to write this as b squared over 4a squared minus c over a. And then what I see there is I have a couple fractions. When I have a couple fractions, and I want to subtract them, what do I usually do? I get a common denominator. What's the common denominator? 4a squared. So this one already has 4a squared. What do I have to do to this one to give it a 4a squared? Multiply by 4a. So this is b squared over 4a squared minus, I multiply the bottom by 4a to get 4a squared on bottom. So I have to multiply the top. It gives me 4ac. I multiplied the bottom by 4a, so I have to multiply the top by 4a. All right, and then I can combine that all as one thing. I'm going to write it as b squared minus 4ac all over 4a squared. All right, so that goes back to what we did a couple sections ago when we learned about adding and subtracting fractions that had a bunch of letters in them. It does, because I'm about to get rid of this square. What do I do to get rid of this square? Take the square root, and I can do square root on bottom. Square root of 4a squared is 2a. So you're starting to see the quadratic formula fall out of this, aren't you? Yeah. All right, so we're going to square root both sides. And I remember that when I do square root, there's two of them. There's a plus and a minus. So I have x plus b over 2a equals square root, plus or minus square root of b squared minus 4ac. And then down on bottom, I can do square root. The square root of 4 is 2, and the square root of a squared is a. Well, I'm almost there. How do I get x all by itself now? I subtract the b over 2a, so x equals. And notice when I subtract the b over 2a, they have a common denominator. They both have 2a on bottom. So I can put it together. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And this is probably the most famous formula in all of algebra. Help if you could see the whole thing. Isn't it what? It is not Schrodinger's formula. It's not the Pythagorean theorem. It's the quadratic formula. So this is known as the quadratic formula. What does that quadratic formula allow you to do? If you have a quadratic equation, in order to solve, all you have to do is plug in the numbers and do the arithmetic, and the quadratic formula gives you the answers. But you can see what this quadratic formula is. This quadratic formula is a very special case of completing the square, which is what we did last time. So this quadratic formula wasn't some super magical thing that somebody designed. Somebody just took a generic quadratic equation, applied the completing the square technique to it, and the quadratic formula just falls right out for you. No, it definitely came the other way around. They definitely completed the square first.
I feel like they
Alright, so let's take this same equation we started this class with. 3x squared minus 12x minus 4 equals 0. We solved it by completing the square and we got answers. Okay? Now let's solve it using the quadratic formula, see if we get the same answers. So, the worst part of the quadratic formula is you have to memorize it. You can't use it if you don't know it. So I'm going to write it down. X equals negative b plus or minus square root b squared minus 4ac, and the whole thing is over 2a. So you need to go home. You need to do some practice with this. You need to solve several equations. You need to write that quadratic formula down several times until you have it memorized. Absolutely positively have to memorize it. There's no other way around it. Well, I suppose you could write it on your sleeve and then try to roll your sleeve up while you're taking your test. But you get caught doing that, you get in lots of trouble. So it's probably not worth it. Oh, he's trying it right now. You should get it tattooed on the inside of your eyelids, I suppose. All right, so really all we have to do with this formula is plug the numbers in. So what's the A number? A is the first number, so A is going to be 3. B is the second number, which is negative 12. And C is the third number, which is negative 4. So all I need to do is recognize what those numbers are, and then I go ahead and I plug it in. So my answer is negative B. That's negative 12. That's positive 12. Plus or minus the square root of b squared. So that's negative 12 squared. What's negative 12 times negative 12? 144. Minus 4. There's always a 4 there. Times a. The a number is 3. The c number is negative 4. All divided by 2a, that's 6. That's 12. Plus or minus, I grab my calculator. 144 minus 4 times 3 times negative 4. Calculator says that's 192. All over 6. The square root of 192 is not a nice number. It's an ugly decimal. So I leave my answer looking exactly like that. Now, here's the problem. Is that the same answer we got last time?
because of 6 and 12.
Well, the only way I can reduce the 6 and the 12 is if I can also reduce over here. But the 192 is trapped inside a square root, so I can't reduce it with the 6. Is that the same answer? They certainly don't look the same. Well, I care. I want them to be the same answer. If I believe hard enough. All right. Well, I'm not a very good believer, so I'm going to go with the facts. So, if I'm not sure, I could do 2 plus the square root, oops, wrong button, 2 plus the square root of 16/3. That's 4.309 more stuff. And then I'm going to do 12 plus the square root of 192. And then I'm going to divide that by 6. 4.309 more stuff. Are they the same answer? You don't see the similarities? All right. Well, you got a 4 and a 4, a 3 and a 3. And then, yeah, those are really the same answers. They just look very different. The answers come out in different forms, but that doesn't mean they're different. They really are the same. The one we got by completing the square, we really ended up with a more simplified form than the form we got when we did the quadratic formula. But that's okay. They really are the same. 4.039, 4.039, and the decimals keep lining up all the way. Questions on that? All right, so let's do a couple more problems with the quadratic formula. Let's say I asked you to solve. I'm going to do an easy one first, then I'll do a hard one. X squared minus 3x minus 10 equals 0. All right, well, x equals negative b plus or minus square root b squared minus 4ac all over 2a. Again, you need to write that down, I don't know, 20 times or so until you get it memorized, however many it takes. All right, so we plug the numbers in. In this case, a is the number 1. B is the number -3, and C is the number -10. So x equals negative b, that's -3, that's +3, plus or minus the square root, -3 squared is 9, minus 4 times 1 times -10, all divided by 2. You want to know what one of the biggest mistakes I see people make on these problems is? They use their calculator. And they'll do this. They'll go -3 squared, and the calculator tells them it's -9. Calculator tells them it's -9, so they put -9 right there. Even though when I ask you to do it in your head, you tell me the answer is +9. Why do I need the parentheses?
Because otherwise it's squaring the number.
Because it does the order of operations. And the order of operations says squares come before minuses. So it squares the number first, it does 3 squared, and then it does the minus because that's the order of operations. So this is one time when I think it's a bad idea to use your calculator. Do it in your head. -3 times -3 is 9, and you'll put the right number there. This number right here is always going to be positive. If you're putting a negative here, you're screwing up. Always got to be positive because we're squaring something. All right, so we did now we can use a calculator. 3 plus or minus square root of 49 all over 2. Square root of 49 happens to be a very nice number. 7. So this is 3 plus or minus 7 over 2. So when the answers come out very, very nice like this, the square root goes away altogether, we generally simplify. So we would do 3 plus 7 divided by 2. So one answer is x equals 5. And then 3 minus 7, -4 divided by 2, -2. Questions on that one? Right. This is a wonderful example of the quadratic formula always works. Here it is. But it's not always the best way. X squared minus 3x minus 10, you should have tried factoring first. Whenever this first number is the number 1, factoring, at least trying it, is pretty quick. You should have noticed this factored as x minus 5, x plus 2, and you would have been done in one step. So that's a trap people fall into. They get a formula, they think they're always going to use the formula. It's not always the best way. Will it always work? Yes, but it's not always the best way. All right, so then you said you wanted a hard one. What makes them hard? If I put them out of order? Okay. Well, what would you do if I put them out of order? You put them back in order. So I'll give you one out of order, and then I'll make it even worse than that. How about if I gave you 2/3 minus 5/6x equals a half x squared? Yay! Love the fractions. Thanks for doing that for us. We're going to do like we always do when we see fractions in an equation. The first thing we're going to do is we're going to get rid of those fractions. We're going to do that by multiplying everything by 6. What's that? Oh, okay. All right, so what's 6 times 2/3? It's 12 over 3. 12 over 3 is 4. Minus, what's 6 times 5/6? The 6 is reduced out. It's 5, so that's 5x. Equals, what's 6 times a half? So that's 3x squared. All right, so first off, don't let those fractions freak you out. You just clear them. Not a problem. What's the next thing you do? You have to get them all on one side and get 0 on the other. And this is my personal preference. I like the a to be a positive number. So I'm going to push everything to the right. So I'm going to write this as 0 equals 3x squared plus 5x minus 4. So that's how I would do it. Is it going to be a problem if a is a negative number? No, quadratic formula will still work just wonderfully. I just find it easier to have it to be positive, so I like to do it that way. My choice. All right, so x equals negative b plus or minus square root b squared minus 4ac all over 2a. I wonder how many times I've written that. I don't know. I mean, I've been teaching for 28 years now, so I teach algebra every semester, sometimes more than one class of it. I've probably written that thing thousands of times. It's kind of create a formula to count it. All right, so negative b, what's b this time? So negative b would be negative 5 plus or minus square root of b squared, 25, minus 4 times 3 times negative 4 all over 6. That's negative 5 plus or minus. I grab my square root, my calculator. 25, 73 you say? Okay, 61. That's because I typed it in wrong. 73, now I believe you. All over 6. Questions on that? It's about as hard as they can get right there, throwing fractions in there. Throwing the fractions in there really cause a problem? Now, once you get rid of them, it's pretty easy. What if I gave you a problem that had decimals in it? You got two choices. One, you can use the decimals, or you can multiply by 10 or 100 or 1,000 or whatever you need to move the decimals over and clear them out too. Or you could switch into fractions and clear the fractions too. That would be harder probably. No, I think it'd be easier to just multiply by 10 if I only need to move the decimal one place, or multiply by 100 if I need to move it two. I think it'd be easier to just do that. All right, so my last two questions of the day before I give you questions. How would you solve that equation? You can't distribute the 2 because squaring comes before multiplying. How would you get rid of the 2? I could divide by the 2. Okay, that's not a bad idea. Do what? I would get a fraction. I'll survive. Do what? And how would you get rid of the exponent?
Use the 5 over first, take the square.
All right. Distribute the x minus 1 squared, which is, I think, the same thing you're saying. That's a horrible idea. Well, it's not a horrible idea. Let me rephrase. And you're not a horrible person. It's an inefficient idea. This is another good example of you should not try to solve this equation using the quadratic formula, which is what you guys are doing. You want to FOIL that thing out and expand it. What you really should do is before you divide by the 2, I would add the 5 over. So I would add the 5, and then I would divide by the 2, and then how do I get rid of a square? Do a square root. This is a good example of the square root method is a much better technique for solving than the quadratic formula is. I better take the square, which I didn't think you meant to be square root. You didn't say square root, you said square. No, not the same difference. In fact, completely opposite differences. And then to get the x all by itself, move the 1 over. All right, so again, just because you have the quadratic formula doesn't mean it's always the best way. What's that? You always use it? I use the quadratic formula a lot, mainly because not only are these fancy calculators graphing calculators, they're also programmable calculators. So I have a nice little program on my calculator called Quad. And so all I have to do is type in the A number, which is 3, type in the B number, which is 5, type in the C number, which is -4. And the calculator tells me the answers are -5 plus or minus the square root of 73 all over 6, which is exactly what we got. And then my calculator also spits out the decimal approximations for me. All right, so this is what math teachers did back before we had laptop computers. So you're giving a 3-hour final and you got to sit there for 3 hours with nothing to do but stare at people as they take a test. It's pretty boring pretty soon. And so I sat down one day while I was giving a final and wrote this program on my calculator because I thought it would be useful. What did I write it in? I wrote it on the calculator. The language on the calculator is a form of BASIC. So this program is written in BASIC. And it's kind of cool because it does give me the exact answer and it gives me the approximate answers. And if the answers come out nice, like that one we saw on that other one, it'll just give me the nice answers. It won't show me all that square root stuff. So that's why I like the quadratic formula, because I can just type the numbers into my calculator and get the answers. Questions? How do you program that? Well, you go to New and you create a program, and then you have to understand the way it works. So you have to tell the calculator to input A, input B, input C. And then if A is 0, that's no good. A can't be 0, right? Then stop. And then I compute this thing called b squared minus 4ac. B squared minus 4ac, that's that part of the quadratic formula. That tells you interesting things, actually. If b squared minus 4ac is a perfect square, like in one of the problems we saw, it turned out to be 49. If b squared minus 4ac is a perfect square, then you're going to get nice answers, because when you do square roots, you get nice answers. If b squared minus 4ac isn't a nice thing, then you get ugly answers. And so that's what you see next, is I have,
Oh, your program is gone. Oh.
no, but I type something in there. Huh. It was. So program input output if alpha d equals 0. Anyway, if d is 0, then you only get one answer. If d is positive, then you're going to get two answers. And it depends on if d is a perfect square or not. You get nice answers. If d is not a perfect square, then you got to do all this output stuff to get the ugly square root answers. And then if d is negative, you get something called complex answers, and that's all there. See, it took me a good 3 hours.
Make my dad do it.
Right.
You could just go online, look up,
Yeah.
type it. I want to pass it out. Or you can just get it.
Yeah, my program's still working. We didn't break it.
You sure about that?
Yeah, it's still working. It's all working. Yeah, it's good. We didn't break it. It's all right. I have it backed up on my computer anyway, so had I broken it, I could have fixed it anyway. All right, so anyway,